Hello! In this video, we'll look at how to access arrays in assembly language. So arrays represent possibly a large amount of similar data, and recall that the index of an array is which element we want to access, and the size is the total number of elements. So suppose we had a 5-element array that was at a base address of 123B478, and that should be consistent, 123B478. And these elements were one word, or 32 bits each. So the first step in accessing the array is to load the base address of the array. So let's say we wanted to access this array and take 2 elements and double them. And suppose variable S0 was going to hold the base address of the array. If it wasn't already loaded up, we could do that with 2 steps. Load upper immediate into S0 of 123B4. That brings in the upper 20 bits. Then add immediate S0, S0, and 0x780. So that will load, initialize base address. Now if we wanted to load element 0, we could do a load word, say into temporary 0, 0 parentheses S0. That will load array bracket 0. Then we could shift left logical, T0 gets T0, and shift left logical immediate, T0, T01 to double it, and store back into the array. We could do the same thing for element 1, but element 1 is 4 bytes later in memory, so we add an offset of 4. All right, suppose we wanted to access an array using a for loop. So let's say we wanted to multiply every element of an array by 8. And suppose S0 already contained the base address of the array, and we'll use variable register S1 to hold the I variable. So we need to do the initialization, add I S1 gets. Actually, we have this code on the next example. Here's, say, loading the base address of the array. Now this is the I equals 0, and we'll compare to 1,000. Now in our loop, we'll check if I is equal to 1,000, if it's greater than or equal to 1,000. If it is, we're done. Otherwise, we need to load array bracket I. So I is in units of words, and so we need to multiply by 4 to get units of bytes. So we'll shift left I by 2 to get the offset in bytes instead of words. Then we'll add that to the base address, S0, to get the address of array bracket I. Now we'll load from 0 relative to that base address to load in the value of array I. We will shift left by 3 to multiply by 8, and then we'll store the result back into the address we've already calculated that was in T0. Now we're ready to do the post operation, I equals I plus 1. So add S1 gets S1 plus 1, and then jump back to the loop and check if we're done yet. So another common data structure is strings, which are arrays of characters. And recall that the American Standard Code for Information Interchange, ASCII, defines a value, a 1-byte value for each key on the keyboard. So for instance, uppercase A is hexadecimal 41, which is decimal 65, B is 42, C is 43, and so on. Lowercase are hex 20 later, they're digits, and so on. And so remember in C that a string ends with a ASCII value of 0, not the character 0, which has an ASCII value 30, but actually an ASCII value, the byte 0. So suppose we had a string cat, and we wanted to know how long it is. In memory, C is 43, A is 41, T is 54, and then a 0. So if the base address, say, were 1000, then at 1001 would be the A, 1002 would be the T, and 1003 would be the null termination. So here's a program to determine the length of the string. We'll start with a length of 0, and while the string bracket len is not 0, while we haven't reached the end yet, we'll increment len. So initially length is 0, string of 0 is a C, so we increment length. Now length is 1, string of 1 is A, so that's not 0 yet, increment length. Length is now 2, string of 2 is T, that's not 0, increment length again. Now length is 3, string of 3 is 0, so we leave the while loop. So here's some code to do that. Let's say that S0 already contained the base address of this array, and S1 is for length. So we're going to initialize length to 0. Add I, S1 gets 0 plus 0. Now we'll check the condition of the while. So we need to go into memory and read the value of str.length. And this example is showing us how to use load byte, and that byte offsets are not multiplied by 4 because the memory is byte addressed. So we'll add, let's say T0 gets the base address S0 plus the offset S1. It'll give us the address of str len. Now we need to use the load byte command, say to load into T1, 0 parentheses T0. That will load str len, load the value. Now if it is not 0, we want to do the body. So if it is 0, we want to exit. So BEQ T1 0. If the value is 0, then we go to done. Otherwise, we want to add one to length. Add T1, or sorry, S1 is length. That gives us our length plus plus, and finally jump back to the while loop. And the while loop starts here, where we're accessing the element of the array. So now we've seen accessing arrays in assembly language. If the elements are a single byte, we use load byte and we just add the base address and the offset. If the load elements were word size, we need to multiply the offset by 4 to go from words to bytes, add that to the base address, and use load word.